Chapter number 10, Gravitation, question and answers. What do you mean by free fall? Dear students, this is object. Here is mass of the object. This is earth. This gravity of the earth attracts every object towards its center. When an object is released from a height, it falls towards the surface of the earth under the influence of gravitational force. So the motion is said to be free fall. Here F is equal to mg. Here the force is also called as mass into acceleration is called force. Ma is equal to mg. Mass cancel. This is A is equal to g, acceleration due to gravity. Once again, what is mean by free fall? Gravity of the earth, here is gravity of the earth attracts every object, towards its center, when an object is released from a height. Look at this, children. When an object is released from a height, it falls towards the surface of the earth. Surface of the earth under the influence of gravitational force. Once again, gravity of the earth attracts every object towards its center. When an object is released from a height, it falls downwards the surface of the earth under the influence of gravitational force. So, the motion of the object is said to have free fall. Second question, what do you mean by acceleration due to gravity? When an object falls towards the ground, from a height, then its velocity changes. During the fall. So, this changing velocity produces what? Yes, acceleration. In the object. So, this acceleration is known as acceleration due to gravity, G. Once again, what do you mean by acceleration due to gravity? When an object falls towards the ground from a height, then its velocity changes during the fall. This changing velocity produces acceleration in the object. This acceleration is known as acceleration due to gravity. Its value is given by 9.8 meter per second square. 9.8 meter per second square. Next one is mass. Dear students, we have learnt in the previous chapter what is mass. Yes, the mass of an object is the measure of its inertia. Once again, the mass of an object is the measure of its inertia. So again, the mass of an object is the measure of its inertia. We have also learned that greater the mass, the greater is the inertia. Greater is the inertia. Dear students, listen carefully. It remains the same whether the object is on the earth, the moon, or even in outer space. Greater the mass, greater is the inertia. It remains the same whether the object is on the earth, the moon, or even in outer space. It means that ವಸ್ತುವು ಭೂಮಿಯ ಮೇಲೆ ಇರಲಿ, ಚಂದ್ರನ ಮೇಲೆ ಇರಲಿ ಅಥವಾ ಬಾಹ್ಯಾಕಾಶದಲ್ಲಿ ಇರಲಿ, ಇದು ಯಾವಾಗಲೂ ಏನಾಗಿರುತ್ತೆ? ವಸ್ತುವು ಸ್ಥಿರವಾಗಿರುತ್ತದೆ. Thus the mass of an object is constant and does not change from place to place. ಅಂದರೆ ವಸ್ತುವಿನ ರಾಶಿ, ದ ಮಾಸ್ ಆಫ್ ಅನ್ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಅಂದರೆ ವಸ್ತುವಿನ ರಾಶಿ ಯಾವಾಗಲೂ ಏನಾಗಿರುತ್ತೆ? ಸ್ಥಿರವಾಗಿರುತ್ತದೆ. ಆ್ಯಂಡ್ ಡಸ್ ನಾಟ್ ಚೇಂಜ್ ಫ್ರಮ್ ಪ್ಲೇಸ್ ಟು ಪ್ಲೇಸ್. ಅದು ಸ್ಥಳದಿಂದ ಸ್ಥಳಕ್ಕೆ ಬದಲಾವಣೆಯಾಗುವುದಿಲ್ಲ. ದಿಸ್ ಇಸ್ ದ ಡೆಫಿನೇಷನ್ ಆಫ್ ದ ಮಾಸ್. ನೆಕ್ಸ್ಟ್ ಒನ್ ಈಸ್ ವೇಟ್. We know that the earth attracts every object with a certain force, and this force depends upon the mass of the object, means small m, mass of the object, and the acceleration due to gravity, g, small g. So the weight of an object is the force with which it is attracted towards the earth. We know that F is equal to ma, that is F is equal to, also we can write m into g. So this is this one. The force of attraction of the earth on an object is known as the weight of the object. Once again, the force of attraction of the earth on an object is known as the weight of the object. It is denoted by W. So this one, the force of attraction of the earth on an object is known as weight of the object, and it is denoted by W. Substituting the same in the equation 14. This is equation 13. This is equation 14. Substituting the same in equation 14, we have F is also write as W is equal to M into G. As the weight of an object, as the weight of an object is the force with which it is attracted towards the earth. So, as the weight of the object is the force with which it is attracted towards the earth. So, the SI unit of weight is same as that of force. Once again, the SI unit of weight, the SI unit of weight is same as that of force. Same as that of force, and it is known as Newton. The SI unit of weight is also known as Newton, and the SI unit of force is also known as Newton. Weight is same as that of force. So, the weight is a force acting vertically downwards. The weight is a force acting vertically downwards. It has both magnitude and direction. Dear students, listen carefully. When the weight is a force acting vertically downwards, it has both magnitude and direction. So, we have learnt that the value of G is constant at a given place. The value of G is constant at a given place. Therefore, at a given place, at a given place, the weight of an object is directly proportional to the mass of the object. That is, weight at a given place, the weight of an object is directly proportional to the mass. So, the weight of an object as a measure of its masses means it is due to this reason that at a given place we can use the The weight of an object has a measure of its mass. Has a measure of its mass. The weight of an object has a measure of its mass. So, the weight of an object has a measure of its mass. The mass of an object remains the same everywhere. That is, on the earth and on any planet. Once again, on the earth and on any planet, whereas its weight depends upon its location. What? Weight depends upon its location. Coming to the next point, weight of an object on the moon. Dear students, we have already learned the weight of an object on the earth is the force with which the earth attracts the object. So, once again, the weight of an object on the earth is the force with which the earth attracts the object. In the same way, the weight of an object on the moon is the force with which the earth attracts the object. Once again, so the weight of an object on the moon is the force with which the earth attracts the object. So the mass of the moon is less than that of the earth. Look at this, children. The mass of the moon is less than that of the earth. Due to this reason, the moon exerts lesser force of attraction. On objects. Once again, the mass of the moon is less than that of the earth. Due to this reason, the moon exerts lesser force of attraction on objects. Let the mass of an object be m. We can write as small m. Let its weight on the moon be w. In this we can write it as small m. Let the mass of the moon be capital M. You can write as small m, and its radius be capital R in small m. So let the mass of an object be m. Let its weight on the moon be w. Let the mass of the moon be capital M and its radius be R. Means you can write as capital R. By applying applying the universal law of gravitation by applying the universal law of gravitation, the weight of the object on the moon will be Wm, means weight of the moon is equal to weight of the moon, and Wm is equal to G into mass of the moon into mass of the object divided by radius square. Once again, here is weight of the moon is equal to G into mass of the moon into mass of the object divided by radius square. This is the important formula. Let the weight of the same object on the earth be We. Here is the weight of the same object. Look at this, children. It is the weight of the object on the moon will be Wm is equal to G into m into m divided by r square m. In the same way, the weight of the object on the earth be We. So, the mass of the earth is capital M and its radius is capital R. Weight of the same object on the earth is We. The mass of the earth is capital M and its radius is R. Here is the table 10.1. Celestial body, mass in kg and radius in meters. The celestial body Earth, its mass is 5.98 into 10 to the power 24 and its radius is 6.37 into 10 to the power 6. The next celestial body Moon, its mass is 7.36 into 10 to the power 22. Its radius is 1.74 into 10 to the power 6. From equation 9 and equation 15, substituting equation 9 and 15, we have equation 9 is G is equal to Gm by R square and equation 15 is W is equal to Mg. Here is We is equal to G into M divided by R square into M. Once again, We is equal to G into M divided by R square. Equation 17. Substituting the values from the table 10.1 in equation 16. Equation 16 is weight of the mass Wm is equal to G into mass of the moon into mass of the object divided by radius square. This is equation 16. Substituting Substituting the values from the table 10.1 in equation 16 and 17, we get, here is the equation 17. So next, substituting the values, we get equation 16 is Wm is equal to G into m divided by r square. Mass of the weight is equal to G into, so this is moon weight. Mass of the moon is 7.63 into 10 to the power 22. So mass of the moon is equal to 7.36 into 10 to the power 22 kg into meter. Next one, the radius of the moon is 1.74 into 10 to the power of 6. Here is 1.74 into 10 to the power of 6 meter square. Once again, mass of the weight is equal to G into 7.36 into 10 to the power 22 kg into meter divided by 1.74 into 10 to the power 16 meter square. We get the answer Wm is equal to 2.431 into 10 to the power of 10 G into m. And here is weight of the earth. Substituting this weight of earth in equation 17. Here is equation 17. We is equal to G into m divided by r square. Once again, We is G into m divided by r square. We is G into mass of the earth is 5.98 into 10 to the power of 24 kg into meter, and radius of the earth is 6.37 into 10 to the power of 6 meters. Once again, We is equal to G into 5.98 into 10 to the power of 24 kg into meter divided by 6.37 into 10 to the power of 6 meter square. Therefore, We is 1.474 into 10 to the power 11 G into m. This is equation 18a. This is equation 18b. Substituting these 18a divided by 18b. Wm divided by We is equal to 2.431 into 10 to the power of 10 divided by 1.474 into 10 to the power of 11 is equal to Wm divided by We is equal to, we get final, the answer is 0.165 is nearly equal to 1 by 6. So therefore, weight of the object of the moon divided by weight of the object of the earth is equal to 1 by 6. We get cross multiplication. Therefore, weight of the object on the moon, once again, weight of the object on the moon is equal to 1 by 6 into its weight on the earth. This is very important. Weight of the object on the moon is equal to 1 by 6 into its weight on the earth. Example 10.4. Mass of an object is 10 kg. What is its weight on the earth? Solution. Mass m is equal to 10 kg. Mass m is equal to 10 kg. Acceleration due to gravity. Acceleration due to gravity G is 9.8 meter per second square. Now coming to formula, W is equal to M into G. W is equal to mass M is equal to 10 kg into acceleration 9.8 meter per second square. W is equal to 9.8 into 10 into kg into meter per second square. W is equal to 98 Newton. W is equal to 98 Newton. Look at this, children. 9.8 is equal to 98 by 10. Here 98 by 10 and this 10 is also cancelled. 98 is remaining. W is equal to 98 Newton. Thus, the weight of the object is 98 Newton. Example 10.5. An object weighs 10 Newton when measured on the surface of the earth. What would be its weight when measured on the surface of the moon? Solution. We already know that weight of an object on the moon is equal to 1 by 6 into its weight on the earth. Once again, weight of the object on the moon is equal to 1 by 6 into its weight on the earth. That is, Wm is equal to We by 6. Dear students, what is the value of We is equal to 10 Newton. So, We is equal to 10 Newton divided by 6 is equal to 1.67 Newton. Therefore, Wm is equal to mass of the weight is equal to 1.67 Newton. Thus, weight of object on the surface of the moon would be the weight of the object on the surface of the earth would be 1.67 Newton. Gravitation questions. First question. What are the difference between the mass of an object and its weight? The difference between mass and weight. First one, mass is the quantity of matter contained in the body. In weight is the force of gravity acting on the body. Second one is it is the measure of inertia of the body. In second one, In case of weight, it is the measure of gravity. ಮೂರನೇದು, mass is a constant. Mass is a constant quantity. Constant quantity. So, in case of weight, weight is not a constant quantity. It is different at different places. Fourth one, it only has magnitude. It has magnitude as well as direction. It has magnitude as well as direction. The fifth point is its SI unit is kilogram kg. In fifth point, in case of weight, its SI unit is the same as the SI unit of force, that is Newton. Once again, mass is the quantity of matter contained in the body. Weight is the force of gravity acting on the body. Second point, it is the measure of inertia of the body. In case of weight, it is the measure of gravity. The third point, mass is a constant quantity. Weight is not a constant quantity. It is different at different places. Fifth point, it only has magnitude. In case of weight, it has magnitude as well as direction. The last point, in mass, its SI unit is kilogram kg. Its SI unit is the same as the SI unit of force, that is Newton. Dear students, the second question is, why is the weight of an object on the moon 1/6 its weight on the earth? Dear students, the second question you have already learnt. Once again I will explain. Let ME be the mass of the earth. Mass of the earth, and small m be an object on the surface of the earth. Let RE be the radius of the earth. According to the universal law of gravitation, according to the universal law of gravitation, weight WE of the object on the surface of the earth is given by WE is equal to GME into M divided by RE square. Once again, let ME be the mass of the earth and small m be an object on the surface of the earth. Let RE be the radius of the earth. According to the universal law of gravitation, weight VE of the object on the surface of the earth is given by WE is equal to G into ME into M divided by RE square. Let M and RM be the mass and radius of the moon. Dear students, here M and RM be the mass and radius of the moon. Then according to the universal law of gravitation, weight WM of the object on the surface of the moon is given by WM is equal to GM into M by RM square. WM divided by WE is equal to RE square divided by ME RM square, where ME is equal to 5.98 into 10 to the power 24 kg. M is equal to 7.36 into 10 to the power 22 kg. RE is equal to 6.4 into 10 to the power 6 meter. RM is equal to 1.74 into 10 to the power of 6 meter. Here WM by WE is equal to 7.36 into 10 to the power 22 into 6.4 is 37 into 10 to the power of 6 whole square into 5.98 into 10 to the power 24 into 1.74 into 10 to the power 6 whole square is equal to 0.165 is nearly equal to 1/6. Therefore Wm by We is equal to 1 by 6. Therefore, weight of an object on the moon is 1 by 6th of its weight on the earth. Once again, therefore Wm divided by We is equal to 7.36 into 10 to the power 22 into 6.37, nearly equal to 6.4 into 10 to the power 6 whole square, divided by Me means 5.98 into 10 to the power 24 into Rm whole square means 1.74 into 10 to the power of 6 whole square. Therefore, Wm divided by We is equal to 0.165, nearly equal to 1 by 6. Therefore, Wm divided by We is equal to 1 by 6. Here is cross multiplication. We get, therefore, weight of an object on the moon is equal to, here, weight of an object on the moon is equal to 1 by 6 of its weight on the earth.